Hello students, this is Mr. Allen. We're going to continue our journey through chapter 7 and we're going to look at trigonometric integrals. In fact, the next section is going to be involving trigonometry as well. Last week we looked at 7.2, which was on integration by parts. This one is obviously new material too. A lot of it goes back to trig identities that you hopefully learned in pre-calculus a couple years ago, and I'll review some of those with you. So our objectives today are to solve trigonometric integrals involving powers of sine and cosine, similarly with powers of secant and tangent, and to be able to solve trigonometric integrals involving products of sine and cosine. So in this section, we're going to look at how to integrate things like this, where we have sine to some power and then times cosine to some power. Similarly, secant to some power and tangent to some power. So we want to leave m and n, those powers, to be positive integers, but we can actually work around that a little bit sometimes too. So to find antiderivatives of this form, we have to break them into combination of different trigonometric integrals, which we can then use the power rule, and I'm going to try to give you an example of that here in just a second. So for example, if I wanted to evaluate the integral of cosine 5x cosine, integral of sine to the fifth power x times cosine x dx, we could use the power rule and let u equal the cosine of x, and then of course du would be cosine x dx. And so we could just basically change this sine into the u, so that's u to the fifth, and then the cosine x dx, that's the du. So we are essentially using the power rule to get from here to here. So some of the trigonometric identities that we're going to use today, and there's actually some more than that, but obviously this first one, which most students are pretty familiar with, which is what we're going to use on our first example. But here's a couple that maybe aren't so familiar. These are the half angle identities for sine squared and cosine squared. Highly encourage you to be familiar with those. All right, so let's look at an example here. So it says find the integral of cosine to the third power x times cosine to the fourth power of x. So what we're going to try to do here is, you can hopefully understand that this cosine to the fourth power x is the higher power. So what we're going to probably do here is we're going to use cosine x as the u. And therefore, if I do the derivative of that, that's going to produce a cosine, or I'm sorry, it's going to produce a sine factor. So we're going to have to, we want to save that guy. So what I'm saying basically is this. If we have sine to the third x, I'm going to write that now as sine squared x, and then save this factor of sine x dx over here, because I know that the derivative of cosine is going to give me sine dx, or something similar to that. Then what I can do is I can use that, remember that last slide we had sine squared plus cosine squared equals 1, but if I subtract this cosine over to the other side, so note that this sine squared x is this equivalent to 1 minus cosine squared x. Notice that I've not changed the cosine of the fourth power x. So basically what I have here now is that's going to be my du, if you will, and this is going to be my u. So now I can distribute this cosine to the fourth power x. So that's going to give me cosine to the fourth power x minus cosine to the sixth power x. This is going to be my du. I can split that up using the sum and difference rule for integration. And now I can go ahead and integrate, remembering though that when you do the derivative of cosine, you're going to get negative sign. So I have to put negative here, but I put the negative out here to the front. And we get a final answer of negative cosine to the fifth x over 5 plus cosine to the seventh x over 7. Again, once you were to this point right here, we could just say let u equal cosine x. And so that's how you'll get those results. Okay, so that's the answer right here. This is the answer to our original integral, which was on the previous slide. I'm not going to go back to that, but that's our final answer. Key idea here was we used some trig identities, and we used the u sub with the power rule. Now these next two slides, I'm not going to go through all of these with you. They are in the notes. They're in this presentation, so if you want to pause this, these are just some general guidelines for using this technique when you have sines and cosines, sines and cosines. So you go from here to here to here. And on the example that we just did, we use this first example. If we have the cosine being to an odd power, we would do maybe something similar to this. I don't really necessarily recommend that you try to memorize all of these guidelines. I think the best way for you to get good at these is just to practice. And I would encourage you to do, if you need to do more than what I've assigned for homework, I would encourage you to do that, because they're not really that difficult. And after you do a few of them, you get the idea. Now let's do one that involves secant and tangent. So if we were to pause the video here and I was just asking, what do you think U would be in this problem? What do you think U would be? So my guess is some of you would guess tangent, but that actually be incorrect here. And so I want you to watch this one being worked out. So here's the thing. If we make this denominator the square root of secant x, if we want to bring that up to the top, that's where we get this negative exponent. So if I let u be my secant x, the derivative of that, so my du, would be secant x tangent x dx. So what I'm going to do is I'm actually going to save one of these factors of tangent. Okay, I'm going to erase my marking here so you guys can see this clearly. So then when we go to the next step, now here's the thing. I need to make sure that I've got my dx or my du to be this secant x tangent x, because the derivative of secant x is secant tan. So I'm going to use one of these factors of tangent. So I pulled that out. That went to here, that extra factor. Now here's kind of a tricky thing. So this is to the negative exponent. So this here is secant x to the first power. If you add these two powers together, you do get secant x to the negative 1/2. So this is kind of a more involved example. And it looks like a hot mess right now. And you might be thinking, how in the world am I going to deal with this? Well, here I've got this tangent squared. Now it turns out that if we use, and I'm going to do a little bit of side work here, if I have that, and I'm not writing the x's, but I'm just going to write sine x plus cosine x squared equals 1, right? So how do you get tangent? You divide, or actually we can do that. We'll just do that. I could divide this by cosine squared divided by cosine squared, right? So that gives me tangent squared plus 1 equals, now what is 1 over cosine squared? Well, that's secant squared. So what I'm trying to tell you now is this tangent squared, I can use this identity to substitute in, and that's what I'm going to do on this next step. So if I was to take this 1 to the other side, that's going to make it negative. So hopefully you can see where that substitution came from. That was a trigonometric identity substitution. Everything else stays the same. Notice now everything here is in terms of secants, and then here I've got my dx. So now I just distribute my secant. Now I'm going to do my u sub. So this is u to the 1/2. This is u to the 3/2, or negative 3/2, I should say. And then this over here is my du. That's my final answer then when I integrate. That's my final answer. Again, I'm providing you some guidelines here for doing these integrals involving secants and tangents. It is very similar to sines and cosines, and that's all I think I want to say about that. And it goes on to this next page. Okay, 2 more things here before we wrap this one up. So now I want to talk about, what if instead of we having, some power of sine times some power of cosine, or some power of secant times some power of tangent, what if it's just sine of mx times sine of nx? In other words, what I'm saying is, what if the problem involved the integral of 7x times the sine of 5x? How are we going to integrate that? So these are trig identities that you're probably not super familiar with. Please note that there is no product rule for integration, so I'm not using the product rule of integration. I'm using these trig identities. Notice that these are not, there's no integrals written in any of these rules. These are trig identities from pre-calculus. So let's say I want to integrate sine 5x cosine 4x. Notice that the 5x and the 4x are different, so I can't just use a regular substitution. I'm going to have to use this formula, and in particular, I'm going to have to use this one here in the middle that involves the product of sine and the product of cosine. So all you do is immediately recognize that m in this case is 5 and n is 4. And we're going to use our rule. In fact, I'll go back to that and show you again. So here's the rule. So I do the 1/2, and then I got to do the difference of m and n, and then the sum. So that's what we're doing here. So I put the 1/2 here. The difference, 5 minus 4 is 1, so that's why it's 1. This is 9, that's why it's 9, because 5 plus 4 is 9. And then I hope you can see where that plus came from. This is just from this rule. I have not done any calculus yet. There's no calculus being done yet. I'm going to go ahead and erase this stuff. Okay. Now let's go ahead and integrate. So the integral of sine is negative cosine. The integral of sine 9x, I'd have to do u sub, letting u in this case would be equal to 9x. So that's going to give me negative cosine 9x over 9. And then go ahead and distribute the 1/2. This is our final answer. Okay. So again, we can see how those, and I think these are actually a little bit easier, but these trig identities here, you got to kind of know those. Notice here, if I do a sine times a sine, I get a minus, and then these are both the cosines. If it's sine times cosine, this is plus, and these are both sines. And if it was cosine times cosine, this is plus, and these are cosines. But everything else is the same. All right, one final thing is I want to mention Wallace's formula. I'm not sure how likely that this would be on the AP exam, but I'm going to share it with you. I'm not going to do any examples of it, so I'll show you that right now. I'm leaving this one up to you. Maybe you'll have a problem on your homework that involves it. It's not difficult. There is an example on the online textbook that you can look at. But basically what this is telling you is if you have to integrate, and this is these are definite integrals, if you need to integrate from 0 to pi over 2 of cosine to the nth power x, you will simply use this rule right here. And that is just the answer. You're actually not doing any integration. So for example, if I asked you to find the integral from 0 to pi over 2 of cosine, let's say 3x dx, you would use this formula right here. So you would do, and I guess I'll just kind of start this one. You're going to do 2 over 3, and that's just going to be the answer, because that is what we're doing here. It's just 2/3, and you can check that with your calculator. And I think I'm going to end that there.